BCE Chemistry, Unit 4, Identify Chemical Environments. So in this session, we're really just trying to focus on if we could identify the number and nature of different chemical environments for hydrogen and for carbon. A chemical environment is made up of the number and types of atoms that surrounds a nucleus. So, as an example, if two atoms, let's say XY, are connected in the same way to the same atom Z, then we can say that the atom X and Y are in the same environment. Although it could get a lot more complicated than that. Let's look at a very simple molecule, methane, right? We have one carbon and four hydrogens. Since we only have one carbon, of course, we have one carbon environment. But look at these four hydrogens. They are all connected to the same carbon in the same way. They are equivalent hydrogens. Therefore, in this molecule, we have one carbon environment and one hydrogen environment. Ethane, well, it appears that ethanes we have more carbons and more hydrogens. But if you look at each and single carbon, this carbon is connected to three hydrogens in an equivalent way, and then next to it there is a CH3 group. And then you look at this carbon on the right, somehow isn't the same. Even if you try to describe it, it would be like this carbon is connected to three hydrogens and a CH3 group, exactly the same as the carbon on the left. Therefore, although we have two carbons, we really just have one carbon environment. And the same thing, although we have six hydrogens, we still just have one hydrogen environment. Okay. When things get a little bit more complicated, look at this propane. Well, for propane, you probably have a sense if it's colored in the same way, it's probably in the same environment. Yes, so we have three carbons. The two carbons on the end, if you are to describe the environment, or another way to look at this is that if you imagine yourself is the carbon, what you will see is that three of your hands are holding one hydrogen each. And then the fourth hand is holding a C2H5 group. Yeah. Okay. And if you are this carbon on the right, that's exactly the same. Three of your hands are holding the hydrogen atoms each, and then the extra hand is holding that C2H5 group. Therefore, these two carbons are actually in the same chemical environment. But the carbon in the middle is different, because if you are that carbon, you notice that only two of your hands have hydrogens on them, and then the other two hands are holding one CH3 group respectively, right? One CH3 on the left, one CH3 on the right. So that carbon in the middle is in a different chemical environment. It's surrounded by different groups, different amount of atoms as the carbons next to it. So two carbon environments and two hydrogen environments. So from these three examples, you should be able to see that sometimes the symmetrical nature of a molecule makes the number of environments less. So the symmetrical nature of this particular molecule, for example, makes both carbons on the sides in the same environment. And if the carbons are in the same environment, the hydrogens connected to the carbons in the same environment will also then most likely to be in the same environment. We normally say that these six hydrogens are equivalent hydrogens. And let's see some more examples to build up the intuition towards it. Now, this molecule, right? So the hydrogen attached to the carbon, the same carbon on the side, these three hydrogens are equivalent hydrogens. They are in the same environment. So that's one hydrogen environment. Similarly, these two hydrogens attach the same carbon, most likely the same environment, because they are connected in the same way. So do these three hydrogens. So we have three hydrogen environments. And how many carbon environments? We have 4 carbons. Each one of them is connected differently from each other. For example, only this carbon has a oxygen double bond. Of course, a different environment. And in this carbon, only 3 hydrogens and then a whole lot of different groups on the side, different environment. Compared to this carbon, you'll see both carbons on the sides are connected to 3 hydrogens, but the blue carbon is right next to a carbonyl group. The red carbon is not, therefore 2 different environments. So, it should be 4 carbon environments here, 4 carbon environments, because including that one, and 3 hydrogen environments. This molecule, you probably get more idea. These 3 hydrogens, same environment. These 2 hydrogens, same environment. That hydrogen in an environment by itself. And then you will have 2 carbon environments and 3 hydrogen environments. The last one, propanol. Okay, so it has 1 hydrogen environment and 2 carbon environments. Let's have a look. So all 6 of the hydrogen atoms are connected in a CH3 group. That CH3 groups on both sides are bonded to the same carbonyl group. Therefore, again, yes, this molecule is symmetrical. So all hydrogens are connected to a carbon that's next to a carbonyl group. So all of the hydrogens are in the same environment.